All right, so I think we've reached critical mass here, so we'll get rolling. Welcome to I guess it's the first Open Science Subcommittee meeting of the year. Good to see everybody. I'm here with, our esteemed speakers for the day, Drew Stevens and Tyler Harmon. We'll be hearing from them in a little bit. Alex Manos is also here. He's the other co-chair along with myself, but he's feeling under the weather, so he'll just be in listening mode only today. So you'll be hearing mostly from me for this meeting. Yeah, we have a good agenda going into the meeting today. As usual, I'm going to start with some updates from mostly TBEP, a couple things of interest, but let me, because we don't have too many people on the call, I'll do a quick round robin of who's online. Just say your name and affiliation when I call your name. So we got Drew,
Hi, Drew Stevens with the GIS Institute.
and then I'll do Tyler Harmon.
Hi, I'm Tyler Harmon. I'm a federal contractor with NOAA NCOS.
See, we got Blake.
Hey everyone, Blake Simmons, environmental social scientist for the Tampa Bay Estuary Program.
All right. Brendan Turley.
Hey everyone, I'm Brendan Turley. I'm with the University of Miami, but I'm actually a NOAA affiliate who works with the Gulf of Mexico Integrated Ecosystem Assessment Program.
Welcome. Carrie.
Hi, everyone. I'm Carrie Flaherty-Walia with the Tampa Bay Estuary Program, the restoration ecologist.
Carly.
Riley Jones, Science Communication Coordinator with TBEP.
Dave Carlin.
Hi, good morning. Dave Carlin. I'm an environmental scientist with the Environmental Protection Commission of Hillsborough County.
Hey, Dave. See. David Eilers.
Hello, I'm David Eilers from the University of South Florida Water Institute.
Julie Christian.
Hi, Julie Christian with the Environmental Protection Commission of Hillsborough County.
John Swartz.
Hey, good morning. Sean Swartz, City of St. Petersburg. I'm the NPDES Program Coordinator.
See, Katie Wallace.
Katie Wallace. I'm the Data Monitoring Coordinator with the Gulf of America Alliance.
John Landry.
Hey there, Sean Landry, Director of the USF Water Institute in Tampa.
And last but not least, Tyler Murray.
Hi, Tyler Murray. I'm a research software engineer from the University of South Florida College of Marine Science.
All right. I think I got everybody. 15 people. That's a record for us. Good. All right. So on to the updates. I have them somewhere. All right, so yes, as usual, I like to start with some updates, things that I think are of interest to this group, things that have been happening since we last spoke. I always start with this slide just to remind everybody we do have a roles and responsibilities document that kind of outlines what we do as a subcommittee. I won't go into the details here of what this is all about. You can read that on your own time. But we also, I think we often forget that we are a subcommittee of the Technical Advisory Committee. We actually have an in-person meeting of the TAC next Wednesday at the Regional Planning Council. So I'll talk a little bit about that later, but that is going to be more of a discussion kind of science vetting meeting that I think will be of interest to a lot of you. So please attend the TAC meeting if you are of interest to that. But we try to provide information that's relevant to the TAC. If there's recommendations that come up from the subcommittee here, we can certainly relay those to the TAC. Just to remind everybody that that's how the structure of this group goes. I want to start talking about Hack the Bay, which was, we talked a lot about that last year. This actually happened in January. This was our first ever hackathon that the Tampa Bay Estuary Program put together. This was kind of our attempt to crowdsource some efforts to develop some indicator workflows that were kind of missing from our um, our catalog of indicators we have for Tampa Bay. Um, it was a competitive event. Folks showed up as teams, and the winner of the event was invited to contract with the Estuary Program to fully develop the indicator workflow that they presented on at the end of the hackathon in January. We have lots of indicators at the Tampa Bay Estuary Program. There are many that we don't report on. There are many that there is data available to report on, but hasn't been really synthesized into a workflow that can easily report on status and trends for that indicator. So the whole point of this hackathon was to have these different teams kind of focus on missing indicators that we haven't really addressed yet as a program. So various wildlife indicators, invasive species, aspects related to human health and well-being. And if you're curious about all the things we care about as a program and the indicators that we use to report on them, you can look at our CCMP, which is our Comprehensive Conservation Management Plan that kind of outlines everything we care about as a program. And so we were drawing on some of the information in the CCMP to try to fill some of these gaps here. We had 30 attendees. I was really pleased with the turnout. It was well attended. There were 5 teams in total, and each team worked throughout the day to kind of develop their own proposed workflow for their chosen indicator. At the end of the day, we had the teams kind of present their concept to us, to a panel of judges that then ranked and scored each team, and the winner that was chosen was Drummond Carpenter, which is a contractor that's based out of Florida, and they chose invasive species to build out their workflow. And so you actually see a little GIF here of their concept. It's kind of a hex-based format where they're using some public data sets from USGS to sort of catalog the invasive species that are found in our region. And so we actually just contracted with them. We finally have a PO in place, and they'll be starting that work very, very soon now. I do suspect, or do expect rather, that probably in December when we have our next Open Science Subcommittee meeting, that they will present more of a concept, or rather the um, finished product or close to finished product for this workflow that you all will have a chance to comment on. But it'll be more fleshed out and more operationalized at that meeting, and you all will have a chance to see that and provide your feedback. So we're looking forward to that. This time next year, we'll have hopefully some data updates on invasive species that can help sort of prioritize where management efforts focus on these components of the bay. So that's the update for Hack the Bay. It was, I think it was a successful event. We had a survey after the event that people provided their feedback, and for the most part, it was very positive. There are some things that we would like to do differently if we do this again, but I think for the most part, people enjoyed the experience. They enjoyed the venue. They enjoyed working together and sort of contributing to this shared vision of how the estuary program can serve the needs of our constituents and partners. So we don't have any plans now to do this again in the future, but it very likely will happen again, maybe in the next few years, being that it was kind of a success, but sort of a novel way to explore how we can crowdsource some of these efforts. Next update, if I think a lot of you are familiar with TBEP tools. This is an R package that we've created, been working on over the last couple of years. This is sort of our one-stop shop for working with a lot of the existing indicators that we have under our tool belt. I think it was first developed back in 2018. We've been building it out ever since, been various releases since then. But if you're not familiar with this, it is an open source tool, open source package that can give you access to a lot of the different data sets and workflows that we use as a program to report on the indicators we care about. And so since our last meeting, we have released a new version of that. There actually are several updates behind that dashboard or that package that you can check out here. But I think the ones that are going to be most relevant for this group is each year, essentially, when we do our State of the Bay reports, I update a lot of the underlying data sets that go into this package. Data sets related to water quality, phytoplankton, seagrass transect data, tidal creeks. All of those data sets have been updated for 2024, and they're available in the package. Other data sets too that are newly available at the beginning of the year, but are kind of a year lagged behind the other ones just because of the processing time associated with them, have also been updated. That includes benthic data and sediment data, so that's in there as well. And then I've also I spent a lot of time earlier in the year overhauling functions associated with fecal indicator bacteria indicators, FIB indicators. I talked about this at our last open science meeting. I didn't initially plan to do a longer presentation, but I talked about a FIB dashboard that we put together that was also kind of falling under that category of data sets that are available but haven't really had workflows developed around them to routinely report on status and trends. So we were working a lot on that, and I overhauled a lot of the functions in this package to work with a lot of the data sets that are available related to the EPC data set, as well as several county partners that provide that information. So if you do want to visit the updated FIB dashboard, it does include information from all of these partners, and all of these updates too have the data set updates have propagated to our dashboards that are available on our website here. Just to show you briefly, I think I provided this at our last meeting, but this is our FIB dashboard. It wasn't quite as built out last time I showed it, but now you can access not only kind of a bay-wide assessment of FIBs, but also data sets from individual county partners. So EPC, Hillsborough County Environmental Services Division, Manatee, Pasco, and Polk. So that is all on there. I don't think folks have really had a chance to wade through the content and digest it, but this is still sort of it's operational. It does update automatically with data updates from the partners, but I don't think I've received a whole lot of feedback from folks on the service this provides, or whether or not it meets the needs of folks that are concerned with managing FIBs in our area. But it's there. Definitely have a look at it. Let me know what you think. I think it's a pretty cool resource, but that's just my opinion. I'd love to hear what others think when they get a chance to look at it. So that's the update for TBEP tools. The other major update that is not an update that we've created, but it does affect a lot of our reporting products. The Southwest Florida Water Management District has released a updated land use land cover layer for our region. The last one that was available was from 2020, so it's been a few years. There's also a update to the seagrass layer that is not publicly available yet, but we're expecting that any day now. But this land use land cover data set essentially covers our watershed. And so we use this data set for a lot of different reporting purposes, but the most important one is related to our habitat report card. That goes back to our habitat master plan, which is a large planning document that sets sort of short-term targets and long-term goals that describes the where we want to be and coverages of native habitats in our watershed. And so we use this data set to update our report card here that describes these different native habitats, and you can see the year associated with each update. And so this portion here comes from the seagrass layer. We're waiting on an update for that, but these two here cover native habitats in our watershed. And so this row down here is an update from the land use land cover layer that was just released. And so you can see essentially where we're at now with the target being met for where we want to be with coverage of these different habitats, and how the change is trending based on the current data set and the previous. And so you can see if the arrow is pointing up or down, it's trending towards or away from our target. And so just a couple updates here. What's kind of new is that we are no longer meeting our target for native uplands. So that's a concern. We're below that. It's now in red and it continues to decline. There's a lot to look at with this report card, but that's the big one that kind of pops out. That will be propagated to a 2-page document that will be updated shortly. And this is sort of the same thing, but kind of showing you the actual numbers as they actually fall out for the different native habitats. So this is also available on our website if you want to get the actual numbers, but nonetheless, you know, we track these things and we try to update them as soon as possible when these updates for the source data sets come available. The last thing I want to talk about is I also try to keep a short list of resources that I think are of interest to this group, just cool things that come across my computer screen since we last meet. An interesting thing that I saw, I was actually saw a webinar on this. This is really relevant to, I guess, the current political climate that we're in. There's actually a number of folks that are doing this, but this group in particular has done a really good job of kind of capturing and archiving some of the publicly available federal data sets that may be compromised. Either they're not available now or their status in the future is not known. It's unclear if they will be available in the future. And so this group has done a good job of capturing that information and making it available on an alternative server that is not owned by the government. So they're doing a really great job. If you were using any of these data sets in the past and you no longer have access to them, it might be available through this group. It's entirely volunteer run, so they're doing this on their own dime. They do have a donation page if you want to support their efforts, but they're doing the good work, and it's encouraging in these times to see that there are folks that are actively trying to preserve these data sets that are really important for not just what we do locally, but the country as a whole. So definitely check them out if you're curious about what they're doing, or if there's data sets that you're wondering where they went, they might be here. Other things, these are some cool papers that I saw recently, obviously related to open science, but sort of related to, you know, reproducible workflows, or, you know, some challenges that people might be facing and sort of how others have addressed them. This is a talk down here by Mike McManus. If you remember him, he was an EPA employee, recently retired, but he gave a talk to the, I believe it was the St. Joseph, St. Andrews Bay Estuary Partnership, to their TAC, talking about some of the work he's done with aquatic survey design, setup, and how he's helped them kind of set up their monitoring program. And the last thing I'll say is, if anybody here is going to surf, I am giving an R training session there. It's going to be an introduction to R, so starting from the ground up. If you've never used R, you can attend that. But that's going to be in Richmond, Virginia, November 9th through the 13th. The conference is, or rather the workshop is the Sunday prior. So if you have interest, definitely sign up. I've given numerous R trainings before, and this one will be no different. But if you want to learn how to use R for the first time, this would be a good one to attend. So that's all I got for updates. I don't want to talk too much more. I want to make sure our speakers have enough time to present their information. But before I hand it over to Tyler, our first speaker, I will pause there and see if anybody has any questions, comments about any of those updates. Okay, well, hearing none, I will hand it over to Tyler Harmon from NOAA. Just some background on Tyler and why he's speaking to us today. Alex actually saw him give a presentation at FLIMS, which is the Florida Lake Managers Society meeting, talking about some of the cool work that he's done. And so we invited Tyler to speak to our group because we think there's potential interest in some of the tools that he's been working on and how folks might be monitoring HABs and or cyanobacteria around Tampa Bay. So I will hand it over to Tyler.
Thanks, Marcus. Can you guys hear me okay?
Yes, I can hear you. And I am seeing your screen.
And on present mode?
Yes.
Perfect. Okay. All right. Again, I want to thank Alex and Marcus for giving me the ability to speak today. As I mentioned earlier, my name is Tyler Harmon. I'm an environmental scientist working with the Harmful Algal Bloom Forecasting Branch at NOAA NCOS, the National Centers for Coastal Ocean Science. I am joined here by Katie Pozwinski. Our branch chief, Kari St. Laurent, will probably pop on a little bit later. But today I'll be talking about a project that I've been a part of since we started this about 2 years ago, titled BloomScope. So I won't continue on without acknowledging the team behind this. This has been a pretty huge team effort given the amount that's already gone into this project and that will go on in this project. Katie Pozwinski is the lead PI that's on this, as well as Rick Stumpf has been a pretty great mentor for us. Myself, Katie, and Sachi have been sort of behind the scenes working on the development side, modeling side, and Lynn Wilking and Chris Holland have been huge in their efforts to basically generate all of the images that we have been doing thus far to build these models. So I'm sure most people here are familiar with harmful algal blooms or HABs, but for those not so familiar, these HABs are quite challenging in both freshwater and marine ecosystems. They impact the clean watersheds by reducing the water clarity, reducing overall dissolved oxygen, which can result in fish mortalities. Depending on the strain, these can also produce water-soluble toxins and thereby impacting human health. HABs, we all know, are quite prevalent in the South Florida, given the impacts of Carnius red tide, as well as Pyridinium bahamense in the Tampa Bay area, in addition to the freshwater cyanobacteria blooms that are quite prevalent in bodies such as Lake Okeechobee. And given the issues regarding HABs in the region, NOAA NCOS has a pretty substantial presence within the Tampa Bay area. We provide tools such as satellite imagery to understand chlorophyll, in addition to our respiratory forecast and to predict beach conditions for the public. But most of you are likely familiar with our HABscope system, which targets Crania brevis from video clips to give estimated densities that feed into our forecast, such as our respiratory forecast. So really the gold standard to collect, or sort of the gold standard to approach to identify the harmful algal blooms that are causing issues is basically to collect a water sample and to view it under a microscope. Scientists need some pretty high-level taxonomic experience in order to identify these bloom formers. In addition, the researchers can also manually count these algae in order to get density estimates. So I'm sure you are more than well aware that this can be extremely time-consuming and exhausting to sit on a microscope 4 hours on end. So how can we address these setbacks and make detecting them easier? Well, given the rapid development in imaging and computational analysis, we can use improved smartphone camera technology along with deep learning modeling to rapidly identify and enumerate these bloom formers, which can then give researchers easier and faster ways to get the data that they need. So this introduces our project BloomScope. The system itself is a coagulation of several different pieces, both hardware and software, that streamline the identification and enumeration process. So the BloomScope system is comprised of a custom 3D printed phone mount, along with a eyepiece attachment, both are which patent pending, that is fitted to a teaching microscope that is quite similar to the one that is used within the HABscope system. Regarding cyanobacteria, we also have a custom 3D printed gridded chamber to aid in the imaging process that you can see off to the image in the left under the objectives. Dinoflagellates like Corynea are imaged in depression slides, again, quite similar to the HABscope system. And overall, the system itself costs about $250. So the basic idea of how BloomScope operates is quite simple. A researcher will start by taking images on their particular smartphone setup. Each of these images are then standardized, and deep learning models are then applied to identify particular bloom formers. Downstream analyses essentially deconstruct each of those images to pinpoint the targeted cells, and we use some enumeration tools in a paper that is actually in review that are then subsequently applied to gather density estimates. Overall, the data accretion results are basically a density-based metric, which is low, medium, and high risk assessments, along with the genus identified within the image. And so in order for us to develop our models, we first start out by essentially congregating and generating our image library. We currently have over about 26,000 images that span across 10 different iPhone and Android models. For the sake of this talk, we're really just focusing on our cyanobacteria library today. We have about a total of 4 different genera, and there's about 2 species or 2 strains underneath each of those. Each phone type has different resolutions and different focal points. And so we applied a strategy to make sure that each of those images are standardized to the other. This involved applying different cropping and padding tools, like you see off to the right, to get that standard image size. And while I'm sure most of this group is also interested in Corynea, dinoflagellates are coming soon within the near future. So now that we have our standard image library, we really need an environment that can handle constructing these models that are built on tens of thousands of images. And so that's where cloud computing comes in. Our libraries are essentially stored on our NCOS servers, and so we constructed a custom batch file that handles the transfer of images over to the cloud storage systems like S3 that is within Amazon Web Services. From there, we can establish our cloud computing instances using instances that have very powerful GPUs to develop our CNN models. The CNN models are really the perfect tool that we can use for this, for identifying phytoplankton. Basically, just given the fact that there's a wide array of different morphologies that the CNNs can focus on. So all of this is really cool stuff, but the big question and the most important question for this group is how can BloomScope as itself achieve these open science tactics? I really believe that there are about 4 different components that BloomScope can achieve these. These include having accessible technology involving public engagement and feedback, commitment to open data sharing, and promoting real-time information. And so the first thing is obviously getting the public involved. We want this tool to be for you. We want your feedback on how we can make things better and more adaptable for your needs, for the people who are actually going to be in the field using this or benefiting from the data that is generated from this system. And so some of the ideas that we have regarding public engagement include generating some high quality and cost training videos, having some in-person training and workshops, and having an overall dedicated support system to really troubleshoot any of the issues that you may have. And so on the accessible technology side, that seems to be one of the main, one of the core components of BloomScope. The hardware is affordable, like we mentioned, and it attempts to use components such as the smartphone that is already in your pocket, therefore reducing the overall cost. The BloomScope software side eventually will have an app that will be available on both Android and iOS platforms for free once it's operational. One of NOAA's goals, obviously, is to promote open science, and with which we will have repositories containing the source code for everything that we use to be publicly available and hosted on sites such as GitHub. Lastly, once the BloomScope product and app is operational, we really aim to maintain the platform with consistent bug fixes and updates, really to make sure that the product is at the highest quality that you can expect from NOAA. And then going along with that, open data sharing and real-time information are, again, some really influential parts of the BloomScope system. All of this is still in the formulation stage, but we really hope to have an interactive interface that you see off to the right. This comes complete with things such as a map showing measurement points throughout the area, addressing bloom metrics, associated genre, timestamps of where it was, or timestamps of it, locations, and so forth. We also aim to have a historical database of measurements if time series data is of interest to you. And lastly, we want to give you the ability to export any data formats that you might be interested in. This could be as simple as a bloommetric output, or you may want to just look at the images yourselves and confirm the samples that were collected there. And so given the nature of the connection between open science and public engagement, there's really a positive value to the open data process. I've already addressed a couple of these already, but there's still much more that BloomScope can benefit from open data. With BloomScope analyzing samples in minutes, this gives resource managers really a unique tool to improve both spatial and temporal coverage in watersheds that aren't necessarily sampled as regularly. We can also use this to expand, or we can use this expanded data rather to incorporate and improve some of the forecasting products that we have within NOAA. Open science also harbors data transparency, which can then build trust in the product itself and encourage broader participation in areas such as giving us feedback on the user-centered design and really to just innovate the product overall. So that's all I got for today. Again, I want to thank Marcus and Alex for letting me talk. If you guys have any questions, feel free to email us at hab@noaa.gov. Katie and I can also answer any technical questions that you may have. And thanks again.
All right, thanks, Tyler. Are there any questions for Tyler? Yeah, Brendan.
Thanks, Tyler. This is great. I know you mentioned it, and I apologize. I think I missed it. Could you go back and explain the relationship with HabScope? I'm not familiar with. I mean, I know HabScope, but I don't know like the status of it and why. It seems like this does what HabScope does, but more maybe. So just kind of review that. I'm sorry. I know you talked about it.
Right. Yeah. Katie, I don't know if there's any specifics that we can highlight regarding HabScope, but I'll kind of build upon that as much as I can. So we're utilizing a lot more capable smartphone technology. Currently, HabScope 1.0 had used an iPod Touch, which I believe was like the 6th generation. So the camera quality has definitely improved with the approach that we're using now. Secondly, I believe HabScope 2.0 uses a Raspberry Pi system that's pretty fixed to the microscope. The approach that we're doing doesn't necessarily need to use all that hardware. It just uses the smartphone in your pocket, and we provide the 3D printed products to you. Outside of that, the models are much more improved. I'm not as familiar with the way that HabScope was generating, or rather the types of models that were used in that. More specifically, we're using efficient net modeling, along with some pretty high-powered graphics cards from our cloud instances that are generating some really great results. Katie, I don't know if there's anything else that you wanted to chime in on that.
Yeah, I would love to. So I just want to highlight that the core team that was involved in HabScope, as you know it today, right, was involved to a large extent, right, in the development of LibScope. We are building on the existing technology, and we are expanding it so it can be nationally relevant. This didn't happen in a vacuum, right? We've been in coordination and in communication with everyone on the HabScope team. That is a valuable system. We're just looking to replace a legacy technology and maintain the operational infrastructure, right? So we don't envision HabScope going away. This is intended to bolster that network and improve the AI detection accuracy and expand it to other species and across the country, from cyanos to like the Chesapeake, right?
That's very helpful. Thank you.
So I've got to ask an open science question. I really like the emphasis on it and how it's an active part of this process. I always find it interesting how different federal agencies interact with open science. As an example, our last meeting, we had somebody from the EPA talk about their process navigating essentially rulemaking or regulatory criteria development, and how open science can support that. But there's definitely many elements of that process that doesn't need to be open for legal reasons. And so I know NOAA has been one of the leaders in the federal government in adopting open science. And I'm curious if you could just kind of provide your perspective on what aspects of this project have really benefited from using open science, whether it's data sharing or developing some of the app code on GitHub. And do you think that this process or this project could not have proceeded as well as it could have without using these tools? Sort of a general question.
Yeah. I'll see if I can try to hit it as much. So I think this is really, at least within our branch, the harmful algal bloom forecasting branch, this has kind of been used as like a sort of guinea pig to bolster that open science approach, especially with with sharing our code and getting things up and running. Obviously, there's still a lot to do with that approach of getting the app up and running. Is it going to be freely available to everybody, or is it one of those things where we have sort of a sign-up sheet where you have sort of password and protected access to it? These are a lot of questions that are still sort of up in the air, but we're in a really good spot to get a lot of feedback from interested people to see what exactly they want to see within this product and this system. Katie, I don't know if there's anything else that you want to chime in on.
Yeah, I just wanted to note that this will be password protected, right? All of the data that is going to be uploaded is not going to be necessarily like, hey, this was this person who took it here, if that's not wanted, right? It will be, the data will be accessible to the public on a web portal, right? Not necessarily the exact GPS locations, right? The goal is to forecast every beach every day, just like HabScope. So we want to expand the network as much as possible, and we have individualized, I guess, operational platform established, right? We have a volunteer coordinator. We have SOPs for how to use it. This isn't necessarily like our first go round, right? Because we've been involved in the HabScope planning. There's just a little bit more red tape because we have kind of taken it back into the federal government. So we're having some challenges with digesting data from like security requirements perspective, right, from individuals. So that's something we're still actively working towards. But the bones of the network itself, we've built off of what we've already established with HabScope. So we have a good foundation for translating this into a broader open science community.
So if people in the Tampa Bay region, whether it's community scientists or local government, if they want to start using this tool, should they just reach out to you directly, or is it? I guess I'm trying to gauge where this tool, where BloomScope is in the development process. It seems like there's still some work to be done. Are you at the stage where you need like beta testers, or how can folks engage with this if you want that feedback?
Yeah, I definitely think that we are sort of getting to that point where we are interested in gathering interested parties for alpha testers and beta testers. One of the things that, as of right now, the models are based off of is purely just culture images. Obviously, that's not representative of what is in the environment. So one of the things that we've done is we've sort of kept a list of interested parties to eventually send systems out to them based on a particular smartphone that they are interested in dedicating to the, gathering images for us. Typically, these are people who already go out and do monitoring for various watersheds or water bodies. So this is just something that can easily integrate into their already existing workflow. But yeah, we're, if you're interested in being involved in this a little bit more, yeah, that hab@noaa.gov email is a good contact to get involved with.
And I'll just add that this microscope we're using for BloomScope is actually the same exact one that's used in the HabScope program. So if you already have an existing HabScope and you want to explore this as a beta tester, that would be fantastic. We have been acquiring microscopes, right? We have been acquiring everything that we need to start distributing these. The only hiccup we have right now is the data ingestion. So if you're willing to work with us on a little bit of clunkiness as we navigate this, right, and you have internal storage that you could use until we find a way, whether it's sending you a hard drive and having you send us those videos and images back, we are looking for what we call those alpha testers, and that means that we're in kind of a silent period where we're trying to get data from the field, test our models. We're not necessarily going to push that information back to you right away, right? So once we validate those models, then we'll move into the beta testing phase where it will be a direct push out through the app or through a web portal type system. But we're still a ways away from the beta testing phase, but we're absolutely looking for alpha testers for sure, especially if you're already doing microscopic identification and taxonomic ID alongside of that, right? That's a critical step for us to be able to use that data in this phase.
Okay, great. I have to ask the dinoflagellate component. How far off is that?
Not really that far off. I think within the next month, we're looking to start utilizing videos of Carenia cultures in house. I also think Pyridinium is on the docket as well. And yeah, we'll be working on that relatively soon and start building models from that.
So we actually already also have two apps, one for smartphone and one for Android devices for the Carenia and the dinoflagellate swimming pattern video, whatever you want to call it, right, aspect of the program. It's available on the App Store. It's password protected, so you can download it, but you won't be able to use it at the moment, right? We're currently in like a transition phase. We've been working with a partner at the University of California, San Diego, who is transitioning to another university. So we're trying to get all of that documentation in-house. But I imagine within the next 6 months, we'll have, like before the next bloom season in Florida for red tide, right? We should have an operational program. And I do want to note that FWRI has actually already been collecting videos. We just haven't been processing AI on them. So again, if you want to collect videos, that would be fantastic for us. That's a little bit easier for us to validate because they're generally speaking single blooms and we can easily identify them from the videos themselves with a manual eye, right?
Well, excellent. Yeah, the dinoflagellate component is of great interest to our area. So we'll be looking forward to that. And I'm glad to hear that you're working with FWRI on that as well. Are there any other questions for Tyler or Katie before we move along? Okay, well, definitely appreciate the presentation and really exciting technology here. We look forward to seeing more of that in our region. So up next, we have Drew Stevens from the GIS Institute. And just some background. Drew has been working with Katie Wallace and others from GOMOD and GOA on developing a Gulf-wide data dashboard. It's we'll talk a lot about what that project is and what it means. So I wanted to give Drew and Katie a chance to share that project with us, but also kind of just talk through, I guess, the history of the project and how open science has played a role in that, and more broadly around how GIS products have embraced open science over the last couple of years. So it's going to be a little bit different format. We've done in the past at these meetings kind of just a discussion Q&A conversation to sort of explore some of these topics, and I think they've worked well in the past. So I wanted to sort of explore that format with Drew a little bit. So I'll start by just asking Drew to introduce himself and his current role and what he does.
Well, I appreciate it. And I'm happy to be here and really appreciate the presentation before this. So, Drew Stevens, I'm in Asheville, North Carolina, and Katie Wallace actually is in the Tampa Bay estuary boundary. She's the Alliance's data and monitoring coordinator. So essentially, she's my boss. My background, I'm a physical geographer by training, and I slipped into forestry for many years. I worked for Esri twice over my career. Once in Boulder, Colorado. That's where I ended up being detailed into the U.S. Forest Service and GIS for quite some time. And then I left to do my own thing for a while and then ended up on the Deepwater Horizon disaster in Homa. And that's where I learned that ocean GIS was really hard because everything moves. It moves at different places at different times, and it's 3D and you can't see it with a satellite. So I started getting really interested in ocean applications and everything that NOAA's been doing so well for so long. And I ended up getting hired as the Esri Ocean Industry Manager in about 2012, and I left about 2020. and I've sort of been on my own since. So the GIS Institute has been around for a while. It's been sort of my side gig for quite a while, and I still have a couple of little forestry initiatives, but my primary work is with the Gulf of America Alliance. And if I could, I'm just going to share two quick screens, and then we can get the banter going back and forth. Let's see. I just wanted everybody, and by the way, I'm going to show you a couple of tabs. Is that screen showing?
Yeah, I'm seeing it.
Okay. I don't see that classic Zoom outline. So that's I'm going to show you a couple of tabs, and I have them already copied into a document that I can paste into the chat so everybody gets them. But the Gulf of America Alliance, it's really built around these priority teams. And it's a really interesting organization because there's a dozen or so folks that are full-time that keep it going. It's sort of legislatively created and approved every 4 or 5 years by all 5 Gulf state governors. And it's really made up of all these thousands of people that have day jobs that also focus on these different priorities. And so data and monitoring is one of them, and that's where I spend most of my time. I'm also a believer that all of these priorities involve geospatial activity. So I got to know the Alliance when I was at Esri, and I supported building this hub. It's an ArcGIS hub. And basically, the Alliance is the regional ocean partnership for the Gulf. So that's a NOAA designation. And we built this hub supporting, regional applications of these different communities. These are all theme maps, if you will. And then we're shifting into some data search capabilities. Instead of popping one of these theme maps up and looking at the data, we'll also have just a completely pure search portal for these open data sets. So so I've been doing this for a couple of years, and along the way, somebody came up with this idea to build a Gulf-wide dashboard that combines, well, the prototype was to say, let's look at water quality across all the estuaries, not just the NEARs or the NEPs, but also some of the other programs. And I was like, okay. And this is how Marcus and I met, because somebody reached out to people from all these different estuaries and said, hey, we want some help figuring out what's going to be a valuable Gulf-wide dashboard. I won't go into the details, but we made some progress, and we had a couple of webinars, and we started looking at buoys, and we started looking at everybody else's work. I'm not going to go into all of these, but we were just looking around, and there you are, at different projects to see what was out there. And then we created a couple of little prototypes that worked technically, but we're still looking for those data sets that are super valuable. And we even got good at hitting live data buoys with Python notebooks, and that framework for the work to make this actually happen is kind of in place. But I'll just go back a couple of slides. The short version is Gulf-wide and valuable are almost mutually exclusive because you all work with these fantastic data sets in Tampa Bay, and the next estuary over doesn't have anything like that. So having a consistent Gulf-wide set of data to pull water quality, which we're pulling from the USGS water quality portal, is kind of challenging. So I'll just kind of get out of that for now. And that's just the sort of how Marcus and I got here. And I've got some other things to share as the conversation keeps going.
So that's a bit of background on the project, and I really like how you phrased it as gulf-wide and valuable. Are It's hard to find that overlap between those two. And it got me to thinking about, something that you and I had discussed when we were talking about this meeting about the pathway from data to, I guess, utility or information, and how that proceeds, and how there's a lot that can happen along that pathway that makes it challenging to, yes, there you go, that one in particular. And I think I prefaced the conversation around sort of my own experience with, engaging with data and users of the data, and how, for the longest time, I've said this a lot to this group, that, I kind of had this mindset that, well, if you build something, people will use it, right? But that's not true. So it's really hard to make something that is valuable. And the secret sauce to that is, I think, working with the end users and the people that need the information. And so I guess I'm a long-winded way of sort of asking the question of, like, where do you see the human component in all of this? Because there's, you could spend your entire career just playing with data, but it's not going to be of use to anybody if you're not producing something that serves a purpose. So my question is, can you expound on that a little bit?
Yeah, well, I'm so glad you brought up the human component. I used to teach intro to ARC info back in the early 90s, and there was always a slide on the first day of a 5-day course that had, the components of a GIS, and it was hardware, software, data, people, and some kind of need. And I used to kind of crack up about the people and the need part. I was like into hardware and software, and data. And now I've come to be completely opposite, because us humans are the success point and we're the fail point. You can have the best of the best data, the best of the best hardware, whatever software turns your trigger, and still creating value and use, and even marketing that use is on that value. It's our job. And if you don't get everybody together, you're probably not going to find that value. So I agree wholeheartedly with you on that. This slide I have up has become my favorite slide of the year, and I borrowed it from one of my colleagues at Esri. And it's kind of a sign of the times. Like, we have so much data out there, from the big Amazon S3 buckets to somebody like me that's just pushing some public open data out of ArcGIS Online. So the data are out there. They're not all completely liberated, especially the big giant buckets sometimes are hard to get to, and there's still some funky formats. But what we're seeing, is a decade now of the growth of open data services. And there's still lots of different formats, but most of the tools can get to read, write, export into those formats. So the services has kind of liberated data, and then liberated open data, in my mind, over the years, just like radio stations stream their broadcast. Data owners are streaming their data. And there's still a long way to go, and lots of metadata issues. And, I don't think we even have time to go down that rabbit hole. But I really like that, we as a technology society we're somewhere in between services and workflows in this diagram in terms of expertise, in terms of wide acceptance. The work, that human component, I think that you're bringing up, Marcus, is in the workflow. It's like, how do we develop a workflow? And we can use that dashboard project as an example, to create some product that has use and value and is open and available for people to consume. So the workflow, having that repeatable, like, hey, you did that in the Gulf of Mexico. I want to do that up in the Northeast area. So having a workflow that's repeatable and having data that are consistent and useful, those are the big challenges. So we live somewhere between this services and this product piece. And I'm not saying we haven't gotten the products. I'm just saying some products you could call GoMod, a product, and it's just always evolving and always getting updated. You could call a dashboard a product that has a beginning, a work time, and an end where it's kind of done. So the scale of the product isn't even an issue. It's just like the human getting there is the big deal. I just want to show the same thing a different way. One of the things, when we're talking about open data and developing an open workflow that someone else could replicate. So we're trying to open the data up and open the workflow up so that different people in different areas can repeat that product. That's sort of my wish and goal. So, we're looking at all these different data sources. Whoops. Let me just get back where I'm trying to get. And, this GoMod ArcGIS hub that we're supporting, it's an open data portal. But what's funny is there's not much data in it. We like to connect to authoritative data sources that get updated by their owners. If I have a bumper sticker made, it's going to say no downloads. I know some people still got to have their own copy, but we're serving communities that need to have the latest, greatest authoritative content. And so we like to just connect to it. And then what we host is maps and apps that consume those data sets. One more way to look at the exact same thing, this dashboard product that we were talking about, the vision for that is to use the hub to get to these different, these are just examples of different data stores and, consume that data. You would add universities, the local estuary programs, all the seagrass folks, all that kind of stuff. But so these last three slides are really different versions of the exact same thing, right? So that's that premise that I think you and I were talking about.
Yeah, because I really like the way you presented that as the project is a data connector, not data collector. Because I do agree, we are definitely, as a data science community, or whatever you want to call it, somewhere in between the services and workflows piece of these. And sort of my question, like with this particular the GoMod Open Data project, that's been ongoing for a couple of months, and I know you've been thinking a lot about where the project is going and how much connecting is going to be done and what the final product is at. And so I'm curious, one of the reasons I invited you to this meeting was, this might be a good opportunity for you to sort of hear from a local community, the Tampa Bay community, in terms of what our needs might be. Because, we already have, a local, products that serve our needs, but where does this particular project fit within sort of the things that we're used to versus, more Gulf-wide data connector service or dashboard?
Yeah, well, I'll start, with the spirit of this group and just sort of talk about my philosophies around open, because there's open data, there's open source, there's open science, and they're all slightly different, and they're almost components of a workflow. These different things. I'm also of the spirit that the tool that works for you is the tool you should use, right? So I used to, I'm not even gonna tell you what I used to. I just think if you like a pen, use a pen. If you like a pencil, use a pencil. And I think most software products can do whatever it is you want to do. I think WebGIS is the canvas we're all painting on. And if everybody is trying to consume or produce and serve, open data, your tool should be able to handle it. So this isn't about software so much. The trick, to being with you local Tampa Bay folks is like, man, the data you are, I'm oversimplifying, but the data that's important to you is your local data. And you go around the Gulf and nobody's got the same schema, much less the same need, much less the same data. And I'll venture off into prediction. I'm an amateur futurist. There are data pipeline tools. They're available in ArcGIS Online that allow you to hit some data source in sort of a model builder kind of way, and you say, I want to hit that source, so it's being served, but the schema doesn't work, and you can put some operators on that do a crosswalk into your schema. I'm gonna oversimplify, and then create a feature service that you host of that feed. And so it's still live. And then you theoretically, let's just use seagrass as an example. Seagrass schemas differ all over the Gulf. But if you could figure out and had the time to just do that crosswalk, that data pipeline, to where each different seagrass data set you're hitting, you make the schema you want and then combine it all out. Theoretically, you could have Gulf-wide seagrass or Gulf-wide oysters. And the tricky part of that is, as with anything in WebGIS, somebody might change their service or change their schema, and so you got to monitor for all that stuff. The other sweet tool of open GIS is Python notebooks, and most folks in my world are fans of Jupyter notebooks for Python. And you can just kick that notebook off, and once a day or once a week or once a whenever, it'll go hit those different sources and make sure you have the latest, greatest. And by the way, you can do a lot more with a Python notebook than you can with, an ArcGIS Online data pipeline, but there's sort of two versions of the same thing. One's a little bit more complex and you got to be into that kind of programming. And the other's a little more straightforward, but we're definitely going to be exploring that kind of solution to aggregating Gulf-wide data. There's no other way to do it. NOAA's marine cadastre is sort of a clearinghouse for seagrass, but for any given location, you can zoom in and find out, oh, that's 4 years old and we just resurveyed this summer. So how we get to the latest, greatest and make it accessible to a large Gulf community, that's a challenge no matter what sport. Oysters, seagrass, mangrove, corals, water quality. And so, this kind of meeting helps me think about how can you all be stakeholders in such a complex thing with in the end, there's a lot of other stakeholders. We sort of
Yeah.
met you because the power that be picked two folks from each estuary to sort of join this call.
Yeah, I mean, I'm not envious of the task that you're trying to accomplish because it is very difficult. And so I think it's just interesting to hear how the project has evolved in scope as well as what can reasonably be done within the time frame. It's not to say it doesn't have value. It's just you're sort of in this space where you're exploring what can be connected and what's reasonable to connect and at what time scale and how you do that. I mean, you brought up Jupyter notebooks. I mean, I think that's a great example of how something can be automated and reproducible and serve it up in a way that it's hitting the endpoint for the data and also producing something that's timely that shows the current data as it becomes available. I mean, that's something that we do a lot here at the Estuary program. I mean, Jupyter notebooks, that's your pen, right? But Core 2 documents, that's my pencil. So that's like the R equivalent of Jupyter notebooks. But so I want to make sure people have time to ask questions. So I'm gonna, I guess, ask one more thing for you to think about, and then maybe open up the floor. But we talk, you brought up this idea of like, well, open science is one thing, open source is another, open access is a different thing. There's a lot of different ways to describe openness. And being that you're a GIS um, uh, guru by trade, you've been very closely connected to Esri products over quite some time. I don't want to even assume how long that's been.
30.
A time. So you've kind of seen that platform evolve over the years, and I think I told you when we first talked, I first used Esri products back in 2007 when I started grad school. And so I've seen it from one format transition to another, but I'm just curious from your perspective, how do you think Esri has sort of adapted over the years to kind of embrace or not embrace open science or open source principles, and how do you see that serving this community or not serving this community?
Well, I'll answer it two ways. One is about the time I started the second time with Esri is about 2012, and they had just hired an oceanographer, Dawn Wright, to be chief scientist. And if you've never been around Dawn, she has memory retention disorder. She remembers everything and every name. And she gathered a bunch of folks around this Esri Ocean Initiative and literally reached out to her Rolodex. She was an Oregon State faculty member. And she invited 50 people to Esri to come beat us up. What formats were we not working with well? What software functionality were we lacking? So we did a day on data and we did a day on software. And Don had Esri President Jack Dangerman's ear, and he gave the marching orders to the dev team to start supporting NetCDF and all these, GRIB and all these truly multi-dimensional formats. And he barked down the development team to make sure these tool requests to handle 3D GIS were big. So Dawn, her influence grew, it's grown globally, and she's been the single human that has pushed Esri into the world of open. The other piece of that change over the last decade, I would say, is that Esri was known for proprietary software and even proprietary data formats, and Shapefile sort of began the breaking of that mold. And now services, WebGIS, it's almost inherently open. The way they've kept, the keys to the financial side of being a commercial software company is they've moved software functionality, if you want to use that tool, to a login style identity. And once you have a login, everything's open. So that's how they've retained their customer base and their income. And like I said, I have all these tabs saved for you guys, but there's a full sort of open page on, well, there's an open page and then there's open science. And, it handles these different pieces, parts that we've kind of been talking about. And by the way, there's some videos around the philosophy there. I'm not going to market Esri, but I'm just saying, the integration with R, that's about almost 10 years old now. Python, notebooks, that's all listed. Esri's got a really strong presence on GitHub. And then there's a whole, open source, some examples plus tools for data management, for analysis. So I'll pass all these along. This is Dawn basically leading that charge into open science. They've gotten it down to where it's also now, this is just an article by Loring Thai, one of their, but this whole open data thing is important, and I'll send you, all these links. With software aside, back to the canvas, web is the canvas we're all painting on. We're using our tools to make sure our data are available and to make sure we can consume other folks' data. And the way I see this, it used to be sort of Esri versus open source in my brain. And now I'm like, nope, it's tools. It's open tools. And I appreciate they've come that way. And I also just appreciate Dawn for leading the charge. But there are a bunch of, scientists at Esri that are so pleased that open science is being pitched as important, and that up and down the corporate structure they're like, yeah, you're right. And then I can't find it at the moment. I saw it earlier this morning, but there was yeah, and there's a bunch of sites in here, but they've even categorized internally the natural sciences, the social sciences, and they're making sure that everyone involved in sales, in application development, that they're all realizing, we're practicing geospatial science, even if you're putting out wildfires or tracking ambulances or whatever you're doing. And that's what's come a long way for them, that even as an outsider now, I'm like, that's good.
Yeah. Well, I have personally been impressed with how Esri has changed over the years. So I guess I'm really happy that Don Wright led that initiative. These links, we can I'll post this document if you want to send that to me, Drew.
Okay, instead of putting it in the chat.
Yeah, I can put it in the Drive folder with all the meeting materials.
Okay.
I could keep asking questions, but I want to make sure other folks on the call, if they have questions for Drew, or just comments, whatever, now's the time to ask them. I think this is a great opportunity to just get his perspectives on GIS and open science, as well as the GoMod project that we started off talking about.
I'll just talk because I can't find how to raise my hand. That's okay. Just a comment. I mean, with we have the CCAR project, we have the Water Atlas project, we have a ton of data that's standardized. The fundamental problem is we don't have the resources to open up the standardized data in forms like APIs and things that could be more useful to other people. And it's not out of a lack of desire, it's entirely out of a lack of money, you know. So as you know, Marcus, but I don't know if there's any thoughts on how that problem can be overcome. Because we could share, we could share 20 something standardized SAV data sets for the entire west coast of Florida, but somebody has to pay for it, you know.
Yeah, my thoughts there are, just this is a weird thing to go to conferences and to meet people that are doing stuff, and then to realize that they own servers. I've actually been able to match make a little bit, and that's that human component of like and what I've learned is the bigger the organization, the less likely someone can host data for you. So, for instance, there's a guy called Jared King at GCUS, and they are officially under Texas A&M University educational licensing, which is super accessible financially to stand up servers, and they're all virtual servers. The only, sort of pricey part of that is, is that an on-premise server, or is that going to be a virtual, Amazon server? But he's been able to, like, in our current environment that y'all were talking about in the previous session, it's like he's been able to scrape some data sets that have since gone dark and host them. Anyway, that's just a little story. But yeah, that's the pain point is how do I broadcast my radio station?
Well, I guess the server issue is, for us, it's not at all an issue. We have tons of servers, but it's the programming of, like an API or something. It's the taking it from the database or from the web application we developed for the purpose that we're being paid to do, and to turn that into accessible data for that you could pull in, for example, or a map service that, allows anyone to pull it in. Anyway, but it's a staff time issue. It's not the technical,
Sure. Well, Sean, I appreciate it, and I'd be happy to talk offline and maybe even stand up another call to go into the weeds a little bit to see what you got and what barriers may or may not be there. I've I've got lots of colleagues that are doing interesting stuff around that, and depending on the tools at hand, often you can skip the API altogether, especially if the data are already inherently geospatial, and it's really about finding a tool to serve that, especially if you've already got the hardware, instead of spending human hours on software development or API development. There can be tools to skip that step sometimes.
Well, I'll reach out. Yeah.
Yeah, I'm assuming we have each other's email address from the invite, but Marcus, if you could make sure that we
Yeah, can I drop your email in the chat? Is that all right?
Sure.
Drew at the GISinstitute.org.
Yep. And someone else had their hand up, just so we don't.
Yeah, I think it was Brendan. I don't know if you still have that question.
Yeah, it's just more of a comment. I mean, I really appreciate the discussion, and something you guys hit upon in the very beginning hits close to home. So I work closely with the Gulf of Mexico Integrated Ecosystem Assessment Program at NOAA, and we produce ecosystem status reports. And we always come back to the question of like, well, what purpose is this serving, or who's the audience? Because I think, like Marcus, what you said is very true, and we all probably know this. You can build the best thing ever, but that doesn't mean people are going to come look at it. So we try to really work closely with like the partners that we kind of have as our end user as to what it is they need. I mean, we work closely with the Gulf of Mexico Fishery Management Council, and we produce these reports that are ostensibly used for fishery management decisions. So they're very much tailored to their needs. But we've also found that they've become useful pieces of information for other end users like academics, for example, or graduate students. And something that we're really trying to push right now is more open science and also online dashboard generation. So they're more accessible and they're not just these 400-page tomes that no one reads. So the struggle is real, and I can commiserate a lot with what you guys have been talking about. So this conversation has been really, really helpful in just understanding the broader issues that everyone's facing. So thank you for everything.
Absolutely. I appreciate the feedback. Just another little anecdote. Um, I serve on my local town council and I got them into GIS. And, I was like, cool. And the cops want a dashboard to do XYZ. And I'm like, I can probably do that in a day or two. It's just because the data are right there, the needs right there, the request is already there, the stakeholders are engaged. It's like, cool. Then this Gulf-wide estuary dashboard, it was just a couple of weeks ago at the Alliance All Hands meeting where we're still struggling with, a requirements document, and that's got to be stakeholder generated, right? But everybody sort of wanting to do this thing sees the value of assessing Gulf health across the estuaries because they're a great geographic spread of polygons. And we were in the room, and the folks that built GC Map were in the room, and this is the what is it? Gulf Coast. It's the water quality a program inventory. So all the programs, thousands of them around the Gulf that have been dabbling in water quality have been cataloged, and this group was building a dashboard to make that available. And they were in the room while we were talking about this stuff just 2 weeks ago at the all hands meeting. And I asked them, like, hey, how long did it take to get your stakeholders engaged around this dashboard? And the main guy just sort of looked around at me with this grin on his face. And he's like, well, it took us a year to do this. It took us a year to meet with everybody. And we did that saving money by jumping onto other meetings, in-person meetings, and grabbing people and saying, and it took them a year to pull all that off. And they just finished the dashboard, and it was like a 3-year experience. And that relieved me because even I believed that somehow I was going to find the magic data and build a dashboard that everybody liked. And it's just not it. Thank you for your commiseration.
It takes time to do these things, and it takes time to do them well. But we figure out how to do them well through these types of conversations, I think.
Yeah.
So we are at time, so I don't want to belabor the point, but definitely thank you so much, Drew, for chatting with us today, and thank you to Tyler for presenting on BloomScope. Really cool stuff going on there as well. I'll end by just showing our upcoming schedule. So I mentioned next week we have our TAC meeting, of which the Open Science Subcommittee is nested under. We are going to be having a discussion about a number of things, but two important things are going to be kind of describing some of the, or walking through some of the management recommendations for our old Tampa Bay Assimilative Capacity Project, as well as a discussion around how a macroalgae monitoring program might look in Tampa Bay. We're also going to have a panel discussion in the beginning from some folks that have been involved in the TAC for quite some time to give their perspectives on the services the TAC provides to our program. Other dates here, just to note, several things coming up. I won't go over them all, but we have a packed schedule, so I won't hold folks any longer on this call, but appreciate everybody. Am I sharing my screen? Yes. Appreciate everybody being on this call, and we will see you on December 10th for the Open Science, the final one of the year, the final meeting. But otherwise, many other meetings in between to get involved with. So appreciate seeing everybody, and we'll see you next time.
And I sent those links.
All right. Appreciate it, Drew.
Thanks, everybody.
Cool. See you later.